So we just talked about the very basics of exponents in section 1.8. Now we're going to jump back to section 5.7 and talk about the rules of exponents and scientific notation. So section 1.8 we covered positive exponents. Now we have to talk about negative exponents. So if b is a real number other than 0 and n is a natural number, meaning 1, 2, 3, 4, etc. Those are the natural numbers. And some people include 0 in that. Then b to the negative n exponent is the same thing as 1 over b to the positive n. And likewise, 1 over b to the negative n exponent equals b to the positive n exponent. So essentially, if you see a negative exponent in the numerator, you move it to the denominator and the exponent becomes positive. If the negative is in the denominator, you move it to the numerator and the exponent becomes positive. So for example, negative 3 to the negative 4th power is 1 over the quantity negative 3 raised to the positive 4th power, which is 1 over 3 times 3 times 3 times 3, or 1 over 81. Okay, if you want, you can try the other 3 right here on your own while you pause the video and then check yourself. So negative 4 to the negative 2 power. Now remember, this negative 2 power only applies to the 4, not to the negative, because there's no parentheses. So that's negative 1 over 4 squared, which is negative 1 over 16. Okay, on 5.7.3, this is where we can see if we have a fraction what we do. So on this one, the x is to the negative 3rd power and it's in the numerator, and the 5 is to the negative 2 power and that's in the denominator. So we're going to flip them. So the x to the negative 3, instead of being in the numerator, becomes part of the denominator with a positive 3 exponent. And likewise, the 5 to the negative 2 in the denominator gets moved to the numerator. So we have 5 squared in the numerator. Then all that's left to do is 5 squared is 25. So we have 25 over x cubed. Okay. On the last one, the negative 7 only applies to the b, not to the 2. So we have 1 over 2, and the b to the negative 7th moves to the numerator, b to the 7th. So we have 1b to the 7th over 2, or we can just write b to the 7th power over 2. Okay, so that's how we deal with the negative exponents. Now we need to talk about simplifying exponential expressions. So we have rules to help us deal with that. So say we have a base to a power times the same base to a different power. Well, to get the multiplication, we keep the base that's the same in both instances and we just add the exponents. So for example, b cubed times b squared equals b to the 3 plus 2, which is 5. Okay, when we're dividing, it's similar, except instead of adding the exponents, we subtract the exponents. So if we had b cubed over b squared, that equals b to the first power, or just b. When we multiply two things together and we raise that whole quantity to a power, we have to apply that exponent to both of the factors. So if we had xy raised to the third power, that's x to the third times y to the third. And the same thing happens when we have a quotient, when we're dividing. I'm not going to write that one out. We'll see an example in a little bit. Okay, if we have a base to an exponent, and that's in parentheses, and then we raise to another exponent, we multiply the exponents. So for example, if we had b cubed, and that whole thing was squared, that would give us b to the 6th, because we multiplied the 3 and the 2. Okay, as we mentioned before, but we'll say it again, anything to the 0 power just equals 1. And we talked already about how to deal with the negative exponents. So let's leave off with this video here, and we'll pick up with the examples in the next video.